So let us start now. So all of you keep reading. Next concept we are going to see is buoyancy, or we can say buoyancy. So whatever it is, your convenient. So what do you mean by buoyancy? First of all, let us observe. So many times, let us start with our real life experience. So while you all notice it, while you are getting the face wash or while you are doing the bath, so when you are suppose you applied the soap to your face, and unfortunately your mug if you are trying to take water, but if you are inserted the mug in a inverted position like ulta, and if you see if you try to push it and if you leave it, is the mug will settle down or it will be automatically will come up? That is what is my question to you all. Many of you are experienced. Yes, please. For example, a ball or anything, if you try to push into the water, then if you release your hand, automatically the ball will come up or the ball will settle down. Any plastic ball or whatever it is, a mug, you can notice it. Everyone? Yes, please. All of you?
Come up, sir.
Yeah, it will come up. If the mug, if you keep it in a inverted position, is the mug will settle down or it will be pushed up, everybody? It will be pushed up. Am I right or wrong? So it will be coming up immediately as soon as if you release your hand. So why? Who makes the bottle to come up? Anybody can tell?
Buoyancy.
Buoyancy. So the concept behind this, whatever the object when it is falls into the any kind of liquid, so definitely the liquid will experience the a force from that. The object which is fall into the liquid will experience the force from the liquid. The force experienced by the liquid is only ways to call it as buoyancy. Now I have sent you, there is a photograph in the group. You can notice it. I have sent you that. Have you noticed it, everybody? Just observe, all of you.
Yes, sir.
Yes. So I will show you that also. So let us understand what is buoyancy. So you all can see while swimming, let us go back to the now swimming case. So while you are swimming, many of you might be went for swimming in the swimming pool or whatever it is. Are you feeling lighter or are you feeling the heavier during swimming? Your body weight. What you feels? Everyone?
Lighter.
Yes, please. When you're swimming in the water, you feel lighter or you will feel heavy? Everyone? Lighter. Now, for example, I'll ask somebody, let me take Mr. Lingesh to carry out one bucket of water. For example, Mr. Lingesh is standing on the ground. I ask him to carry one bucket of water fully, one bucket of water, and ask him to walk. Now, he is struggling to lift the bucket and like slowly is with a lot of struggle he is trying to move forward. Now Mr. Same Lingesh is standing inside the water and he is carrying a bucket of water. Now you tell me, he will feel easy to carry or difficult to carry? Anybody? Compared to the ground, he will feel easy to carry or difficult to carry? Any one of you? Yes, please. All of you? Easy to carry. So that is the reason you can see you can easily carry a bucket of water or a big drum or whatever it is. If you are inside the water, smoothly you can take it and you can go. But if you are carrying it outside, it is difficult to carry. So what is the concept behind how you can make it? Of course, outside also there will be a buoyancy force. Buoyancy force is exerted by everything. Every kind of fluid will experience that. So that is what I'm saying. So when you push, you can see a load bucket of water in the water, it is very easy to carry because inside the water, a bucket of water is experiencing some other force which will make us to feel lightweight. So let us take this another thing. As we are inserting the mug in inverted position while you are bathing, are you getting any water inside the bucket, inside the mug? Are you get any water? Just you put the bucket, we can say like inverted position, the mug. Are you getting any water if you lift it up? Anybody? Please respond. All of you. So now, for example, I'm having one bucket of water. You kept the mug in an inverted position. Now, are you people able to get the water? That is what I'm asking. If you keep on pushing, as soon as if you release your hand, immediately again the mug will come up. Am I right or wrong? Without any water. Is it right, guys? Nobody experience anytime. I'm asking you only, Ravi. Yes?
Yes, sir.
Yes. Now, same way if you have noticed it, or else you can take. You are all are having a water bottle. Am I right? So everyone you can take the empty water bottle and try to push it into the bucket of water or whatever it is. Now, if I push this, you can see how does this empty closed plastic bottle, if I leave it, is it floating on the surface or it will be settled down? Your water bottle, if you drop in the water, is it will float or it will settle down? Everybody?
Float.
It will float. Clear, everyone? So now, let us try to answer this question, how it will float. Who makes you float? Now, if you notice it, so now, if you take your empty water bottle, you all will be having the empty water bottle in your home. So just you can take, close the closed empty plastic bottle and a bucket filled with water. Now try to push this bottle into the bucket with your hand. So with your hand, you are trying to pull so that you are applying the what force? Anybody? What force you are applying? External downward force. External downward force. So now you can see, you will feel, definitely you all will experience, there is an upward force on your hand from the bottom. If you are trying to push the empty water bottle, while you are pushing it down, from the bottom you will experience it, somebody is pushing your hand upwards. If I am wrong, take immediately, now itself you go, you try to push the water bottle, from the down you will experience it, somebody is pushing your hand upwards. Are you clear, everybody? Push the bottle further down to the bottom of the bucket. More and more you push, you can see, you release the bottle at the bottommost. What you will observe, as soon as you remove your hand, immediately the bottle will bounce back to the where? Everybody? Bounce back to the surface of water. How it will be happens? That is what is our question. If you are having an empty water bottle, you can try once. If anybody will try, and you can share your experience. Okay. Now, what will happen, everybody here? What is the cause? How the water bottle comes up when I push it down? Remember, because the gravitational force, which is basically equals to the weight of the bottle, which is act vertically downwards or vertically upwards. Everybody, can you tell me? If it is an object, the gravitational force, which will act always downwards or upwards? Please loudly speak, guys.
Downwards.
Downwards. So gravitational force which will act downwards, which is equals to weight of the object. Please remember, weight of the object. That is what is the always act what direction? Always act what direction, guys? Downward direction. Please remember, weight of the object is always acting downward, vertically downward direction. Now, but inside the water, remember, there is another force which is acting on the bottle in the upward direction by water. Not only water, any liquid. Liquid will exert the upward force on this immersed object. This upward force on the bottle is always greater than the weight of the bottle. Then the bottle will come and float on the surface. Again, I'm saying you, the force exerted by the liquid, in what direction, guys? Liquids always will exert force in what direction? Speak loudly. Upward direction. So, this upward direction, the upward force is greater than weight of the object. Weight of the object. Then, if you release the bottle, the bottle will bounces back to the surface of water. Are you clear, everybody? You understand what I'm saying? All of you? Are you understand, Amma?
Yes, sir.
Yes. Clear, everybody? So now, for example, now there is a question for you. You might be asked, sir, if I keep the water empty, just one bucket of water I kept, no object is immersed. Now, does it a buoyancy force is exerting by the liquid? Anybody can tell? Is it exerting or not? Any one of you? No object is immersed. So, does it water is exerting any buoyancy force? That is what is my question. Anybody? Please respond. Keep it in mind, buoyancy force will come into the play only when any object is immersed in the liquid. Are you clear, Mr. Lingesh? Mari, what I'm saying? Shivani? Only buoyancy force is exerted. It will be coming to the play when? Only when it is experiencing what, guys? It will experiencing the immersed object. Any object is immersed in the liquid, then only the liquid will exert the force. That is what you have to remember. That upward force which will exert the object is only called as, we used to call it as buoyancy, or we can say upthrust. Upthrust, or we can say buoyant force. Buoyant force, and this phenomena is call it as, what is to call this phenomena, everybody? Yes, please. Buoyancy. Okay, so now everybody see that. So what will happen here? But when I apply my hand, if I apply the external force, by this time bottle is floating or sinking? Anybody? Now the bottle is sinking or floating when I apply the external force. All of you, please respond. If I keep the bottle immersed in water with external force, so what is happening, guys? The bottle should be going down or coming up. If I am pushing with my hand, is the bottle is going up or down? That is what is my question. Everybody, speak loudly, guys. If I am pushing with my hand, is that I am applying the force on the bottle. Now the bottle will go downward or upward. Everyone?
Downward.
Downward. You understanding? So now listen, everybody. The bottle is having certain weight. The weight of the bottle is equals to mass of the bottle into acceleration due to gravity. So this weight of the object always will act vertically what direction? Vertically downwards or upwards? Vertically downwards. And when the object is immersed in the liquid, immediately there is a force which is acting upward by the liquid. What is that force we used to call it as? You can see. What is the force which we used to call it as? Upward force. What is the force? All of you? Upward force. Purima. So now upward force is only we used to call it as. What force we used to call? Which is exerted by the liquid. What is the force we used to say? All of you? Buoyant force. Now, weight of the object is, listen here, weight of the object is exerting downwards. Weight of the object is exerting downwards. And my external force also exerting what direction? External force also exerting what direction? Speak loudly. Downward direction. Do you understand it? So both are same direction. Now upward force only will exiting in upward direction. That is what we used to say buoyant force. So now if there is no external force, what is happening? I notice that bottle will come up. Means whose force is greater? Upward force is greater or weight is greater? Weight of the bottle is greater. Which is greater if there is no external force is applied? Yes, everybody? Please respond. All of you. If there is no external force, bottle is coming up. So whose force is greater? Upward force is greater or weight of the liquid, weight of the object is greater? Which is greater, guys?
Upward force.
Upward force is greater. That is why bottle comes up when it is no external force. Now my question is, I want to find the external force. How much external force applied by me? If suppose they will ask you, that is the first thing you have to remember. So always keep it in mind, like a resultant force in class 8 you will study. So what is the resultant force in formula? Can you tell me? The forces which are acting in all the directions, addition minus the forces are acting in opposite direction. Am I right, everybody? Suppose this is F1 and this is F2 and this is F3 and this is F4. So we will make F3 and F4 addition, which is equals to F1 plus F2. Am I right or wrong, guys? Resultant net force. 8th class, chapter 1, you might be studying. Yes or no? Same direction, all the forces are added. Opposite direction, we have to subtract it. So net, F net is equals to, what will happen? F1 plus F2 minus F3 plus F4. So if I do it, I'll get the net resultant force. Am I right or wrong? Speak loudly, guys. Shivani, understand? Agalya? Now, if you observe, I want to find same way here. What is the external force applied? Can you tell me? What is the formula will come? External force and weight of the bottle acting same direction. So what will happen? External force is F2 plus weight of the bottle is W, which is equals to, what is that force? Upward force. Upward force is what force? They have mentioned here. Upward force is only buoyant force, which have been taken as F1. So this is the formula. Now I want external force. So can you tell me what is the external force? F2 is equals to, everybody? You speak Ra, everyone. Formula you cannot write. F2 is equals to, what will happen? Yes, please. If you, whenever you want to calculate the external force, what is the formula, guys? Buoyancy force minus weight of the object. That will give you the external force applied on an object. That is what you have to remember. Anybody having any doubt, you can ask me. Same direction, we have to add it, which is equals to the forces exerting in opposite direction. So the F2 means external force, F1 means upward force, W means weight of the object. So F2 is equals to F1 minus W. This is the formula. Actually, external applied force. You want, you can write external applied force. External applied force is equals to, okay, upward force minus weight of the bottle, or immersed object. You can write it anything. That is what you have to remember. Are you clear? Abhirami, Gokul, Mari, any doubt, Mari? Pranav?
Sir,
Yes.
sir, how can we find the upward force, sir?
Upward force, I'll teach you. Just wait. That is, there is a formula. Later we'll study that. Clear?
Yes, sir.
Yeah. You don't worry about it. Just I'm saying. Clear? Understand, everyone? The formula will derive, Mari. I'll teach you that. Don't worry. Clear?
Yes, sir.
Yes. So this is what. So the upward force exerted by the liquid. When the liquid will exert the upward force? Anybody? I told you already. When the liquid will exert the force? Hasini, Sanjay,
When there
Sam?
is pressure outside.
No, only when an object is immersed. That is very important. If any object is immersed in the liquid, then only there is external force from the liquid. That is called it as a upward force. If there is no object is immersed, then no buoyancy force. Puriyama, ellame understand amma? Clear, everybody? All of you? Yes, please respond, everybody. That is what you have to remember. So right, the upward force exerted by the liquid. Hasini Sudhakar, do you understand? I'm calling you. Upward force exerted by a liquid. The upward force exerted by the liquid on which object? Nivedan? Liquid on on a body which is what? Kept outside or immersed?
Immersed.
Immersed in it is known as upthrust. Upthrust, or we can say buoyant force. So please remember that. Any doubt, anybody can ask me. And this tendency is only call it as buoyancy. So write it. The tendency, Sam, Purima, Sam, Gokul, the tendency of a liquid to exert and which force? Downward force or upward force? Everybody?
Upward force.
Upward force. So upward force, what is another name? I said, you can see. What is another name? Yes, please. What is
Thrust.
another name of upward force? Everybody?
Thrust.
Upthrust. Thrust kadayad mari, upthrust. Thrust means we studied what? Before class, we have studied thrust.
Perpendicular.
Thrust means what? Acting perpendicularly normal to the surface. This is call it as a thrust. Am I right or wrong? Everybody? Yes? All of you? If the same normal or perpendicularly from the bottom it is acting, that is call it as, what is to call? Upthrust.
Yes.
Okay? Which is exerting perpendicularly. So very simple it is. Okay? To exert
Sir,
an
one doubt,
upward.
sir.
Yes.
Will the object totally immersed or will it
That is what I am
float?
going to say you now. Very good. Good question. Now that's what we are making. The tendency of a liquid to exert an upward force on a body immersed partially or wholly. Wholly means what? Completely. In it is known as buoyancy. Okay, Omari, now clear? Girls, Shivani, Alfin,
Yes, sir.
Hiroshi. Yes.
Sir.
Okay, so this is the most important one. Anybody having doubt, you can ask me. Clear, Abhirami? Gokul Raja? No response at all. Hasini? Yes. So please make it.
Sir.
Yes. That is what it is. Okay, wa?
Sir.
Yeah, ask me.
Sir, if we give more external force, the object will reach the bottom, no, sir?
Yes. But if you release your hand, if the upthrust is greater than the weight, then the bottle will come up. Do you understand?
Yes, sir. Thank you, sir.
Yeah. Do you understand, Shivani? Are you clear? If
Yes, sir.
you release it, it will come up again. Okay?
Okay, sir.
Sir, if the weight of the object is lesser in amount means the upthrust force will be more, sir.
Upthrust will be. If the weight of the object is less, then the object will float. Compared to the buoyancy force. That we will study, Mari. That all the cases I will teach you. Don't worry. You just observe.
Yes.
Okay, clear everyone? Do you understand, Amma? All of you?
Yes, sir.
Yes. Now, we are going to study what is the magnitude of upthrust depends on. That is the most important one. Okay. So magnitude of, as I said, buoyancy force experienced by not only completely immersed object. So either completely immersed or partially immersed. Your choice. It is completely immersed or partially immersed. Both objects will experience the buoyancy force. But keep it in mind, when they will experience the buoyancy force, this is the most important point I'm saying you. Nobody knows, only if you are learned, you can. So observe very carefully. Basically, we will never discuss about it. Imagine now, if suppose there is a same liquid, Lingesh, Kishore, everyone's here. Same liquid in the 2 containers, same liquid in the 3 containers, same height, all of you observe. And object is also same. Object is also same. Now, in this only 1/4 of the object immersed. What is that, everybody? Same object. How much is immersed? Yes, please. 1/4 is immersed. Second case, half of 1/2 is immersed. Here, completely immersed. Same object. What is that? Everybody? Same object. Clear? Ellame. Same
Mass
object
weight.
and same liquid. Same liquid. So same liquid and same object. So when it will be maximum buoyancy force, keep it in mind. Whenever the object will completely immerse, it will sink or float secondary. Whenever the object will completely immerse in the liquid, then it is experience the maximum buoyancy or buoyant force. Kavya, understand Kavya what I'm saying? When the object will experience the maximum buoyant force, everybody, when it is
Completely immersed.
completely immersed. That is you have to remember. Anybody having any doubt, you can ask. Are you clear, everybody?
No one doubt, sir.
Yes.
You're saying that it's the same object, sir. Then how in the first stage it is emerging?
That's
That
what
means
I'm saying. You take your
1/4.
water bottle. Imagine, Mari, you take your water bottle. You apply less external force so that you can keep to certain depth. Do you understand what I'm saying? Only half of the bottle is
Then
immersed.
without external force, it cannot be withstanded, sir.
Then if it is the heavier object, it will go and sink. Do you understand, Mari?
Yes, sir.
That is what. That is the cases, conditions. Object will sink or float within the liquid, outside the liquid. That is all we'll discuss it. Okay, wa?
Yes, sir.
That is. So when any object will experience the maximum buoyancy force, maximum upthrust, everybody,
The object is
if
completely
the object
immersed.
is completely immersed. That is what you have to remember. Now, second one, next one. Magnitude of upthrust depends on, or else you can write factors affecting magnitude of magnitude. What do you mean by magnitude? You all knows that. What do you mean by magnitude? Anybody? Amount of, that is what number. Magnitude of upthrust. First one, it will be depends on the density of fluid. Density of
Sir, upthrust in the sense buoyancy.
buoyancy. That is what. Upthrust means buoyancy only. Clear?
Yes.
Yeah. So density of the liquid. For
Sir,
example.
then buoyant force.
Buoyant force also same, Mari. Same way.
Yes, sir.
Buoyant force, buoyancy, upthrust, whatever it is, same. Are you clear, everybody? Now see. Density of the liquid. For example, if I try to jump into the normal water, like that is what river water you can take. If I try to swim in the ocean water, salt water, if I try to swim in the honey, let me take honey. If I try to swim in the glycerin, you can take. Do you think that every cases you will experience the same buoyancy force? Anybody? Yes, please. Respond, guys.
No, sir.
No. Do you understand, everybody? So, the densities are not same. Then the body will never experience the same buoyancy force. Understand, Shivani? What I'm saying? Kavya? So, all of you keep it in mind. Greater the density of a fluid is increases. Density of a fluid is increases. Buoyancy forces also. What will happen? Everybody.
Increase.
Buoyancy force also increases. So a body will experience greater buoyancy force or lesser buoyancy force when you are swimming. Suppose compared to the normal river water and ocean water. If you are trying to swim in the river water, if you are trying to swim in the ocean water, where you will experience greater buoyancy force? Anybody can tell? Yes, please. River water or ocean water? Everybody? Ocean water. Density of river water is less than density of ocean water. So, buoyancy force exerted by ocean water is greater or lesser? Everybody? Yes, please. Greater. Are you clear, everyone? That is why, based upon this concept, I am asking one beautiful question. Now you tell me, if you want to swim in a river, if you want to swim in a ocean, in which one you will easily will swim, and where you can swim, where you will feel more lighter, or river water or ocean water? Anybody? That's all. You people are not at all having any ideas. Anyone?
So ocean water.
Yes, please. All of you. Suppose, why ocean water? How?
Because
Sir,
you will
because
not
the
easily
density is
sink
more in ocean
inside.
You
water.
understanding? Yes. So in ocean water, we are experiencing the greater buoyancy. Do you understand, everybody? Greater
So it helps
buoyancy
us to
compared to
float.
the river water. So where you will feel more lighter? Where you will feel more lighter? Ocean water or river water?
Ocean water.
Ocean water. Do you understanding? That is why it is easy to swim where? It is easy to swim in the ocean water compared to river water. Okay, wow. What is the reason, everybody? Greater the buoyancy force, easier it will be to swim. So who will exert the greater buoyancy force? Ocean water or river water?
Ocean water.
Ocean water. Why? Because the density of ocean water is more than the density of
River.
river water. So please note it. Very, very important. Any doubt, anybody can ask me. Asani Sudhakar, understand? Mr. Kishore, Laksha, Mukesh Kalyan.
Yes, sir.
Yeah, please write. Okay. So that is the first factor. What is the first factor which will be affecting the magnitude of buoyancy? Everybody?
Density.
Yes. All of you? Next, second factor. Second factor is the volume of the liquid. This I will teach you, don't worry. The volume of the fluid. The volume of the fluid displaced by the body. Displaced by the body. So that is what is the second factor. What is the volume of the fluid displaced by the body? Let us see that, everybody. For example, I'll ask you to swim all the boys. See that water is present. Imagine like 1000 ml. What is the water, everybody? How much ml is there? 1000 ml. Clear, everyone?
Yeah.
Now, I'll ask you to put, suppose, let me take now. I have put 1 rupee coin. Now, definitely some water will displace and they will be collected into the some beaker. Am I right, everybody? Yes, please.
Yes,
Now, again, I fill it 1000 ml. Instead of 1 rupee coin, I will put 5 rupees coin. Now, do you think the same amount of water will be displaced by the coin, 5 rupees coin? Yes, please. 1 rupee coin, if I insert in the water, it has been displaced some amount of water that have been collected. Now, instead of 1 rupee, I put 5 rupees. Do you think the same amount of water will be displaced from the beaker?
No, sir.
No. Or else let me take, I have put 1 kg mass. Now 5 kg mass I put. Now 10 kg mass I'll put. Now tell me, each one separately. Do you think that every time same amount of water will be displaced? Everybody?
No, sir.
No. So that volume of the fluid displaced by the immersed body, if you are displacing more water, or sorry, more fluid, you are experiencing the more buoyancy force. If you are displacing the less water or fluid, then you are experiencing the less buoyancy force. Ellame puriyuma? Do you understand what I am saying, everyone? Yes. The volume of the fluid displaced by the body, if it is greater, if you are displacing more buoyancy force you are experiencing. If you are displacing less buoyancy force you are experiencing by the liquid. That is what you have to remember. Anybody having any doubt, you can ask.
Sir, displacing which substance, sir?
Fluid. When you jump into the water, suppose Mari, you are having a 1000-liter bucket of water. Fully it is, till the edge it is. Now, you jumped. And definitely some water will be fall down. Am I right or wrong? Yes?
Yes, sir.
Yes. So whatever the water which is displaced, I will collect it into the beaker. Are you clear?
Yes,
Now,
sir.
you will come out. You will come out I will ask Mr. Lingesh to jump. Now, do you think that Lingesh time also some water will be displaced? I will collect it in the another beaker. Now you tell me, the water displaced by your body and water displaced by Lingesh's body, is it both are equal?
No, sir.
No. Abhirami, you are not understanding my question. Do you understand, Abhirami? Are you clear? So, individual body I am asking. So, the force experienced by the body, which body? Immersed body, is depends on how much it is displacing. The liquid volume of the liquid displaced by the body is the second factor which will affect the magnitude of thrust. Greater the volume, higher will be the buoyancy. Lesser the volume, lower will be the buoyancy. So please note this point, everybody. Niroshi, understand Niroshi? Alfin, I'm calling but no response. Are you clear, everyone?
Sir, it's dependent on the volume that is displaced.
Yes, volume of the displaced liquid. Volume of the displaced liquid by the immersed portion of the body. Understand, Kavya, Shivani, everybody? Yes,
Yes,
Mr.
sir.
Pranav, Sam,
Yes.
Mr. Prithvi, that is what. So, if your body is displacing more liquid, so you are experiencing more buoyancy force or less buoyancy force? You are experiencing more buoyancy force. If your body is displacing less liquid, then you are experiencing less buoyancy force. That is what you have to remember. Okay, guys? Please respond, guys.
Yes, sir.
That is what. So please make it. Okay, meeting is going to end. Join back. I'm sending the link. And then we'll make cause of buoyancy. Then we'll end the today's class. Do it fast, everybody. Clear any doubt? So what are the two factors affecting the buoyancy, everybody? What are the
Density
two
of the
factors?
fluid and the volume of the fluid displaced.
Now Kishore is having doubt. Sir, if the plastic ball floats